Hello, welcome back. Let's solve Leetcode number of islands. The Leetcode number 200. Okay, so we have an m times n matrix, and we have two values. One represents for land and zero is represent for water, and we need to return the number of islands. Okay, so an island is surrounded by water. uh, okay, it means we need to count the number of uh, the number of land, right? We have the number of land, which is the number of one. Okay, so for this example, we can see we have all the number one can connect together. So we can, so our output is one, and for the example two, we have these four ones can connect together, but uh, this this one couldn't be connect with any ones, because all adjacent values of this one is zero. uh, all of them are zero, so we only count this one, and we have two number ones here, they can connect together, so we have three islands, right? One, two, and three. Okay, so well, for this problem, this is a very classical breadth first search problem, right? Because we will check for each position, and then we will increase the number of islands if we are checking for, if the value that we are checking is 1, and then from that position we keep expanding to 4, we keep expanding to 4 adjacent positions, and we can spread it out, and then we can check until we met 0, so we stop, and then once we finish the check for every position in the matrix, so we have the answer. So that's all for the idea. That is a very classical breadth first search problem. Okay, so let's dive into the implementation. Okay, so I think let's declare a variable for the number of islands, right? We have islands is 0, and finally we will return islands. Okay, we will need a 2D array, a boolean visited, to keep track if that position is already visited or not, right? It's new boolean grid. Okay, so let's call rows equal to grid dot length, and columns is rows and columns equal to grid 0 dot length. Okay, visited is new boolean rows and columns. Okay, and then we will have a for loop to check for every position in the given 2D array. I 0, I less than rows, I plus plus, and for j starting from 0, j is less than columns j plus plus. Okay. Okay, so if we already visited the position I and j, okay, so we will ignore the remaining step, right? We will continue. Else, what we do, we will uh, start visit it, right? Let's declare queue, right? In a queue that we will use for the breadth first search algorithm. New array queue. Okay, and okay, so we only start if we only count, we we only we only increase the number of islands if the current position is a len, right? It means the current position value is 1, right? So let's check if print at I j is 1, so we will add to the queue of last new int I and j. Okay. Okay, so now we will expand and check for 4 adjacent positions, right? Why q is not empty, is empty. Okay, so what we do, we have u is q. Okay, we have xy is q point last, right? And then we have u is xy at 0, v is xy at 1, right? We will check if u is less than 0 or v less than 0 or u greater than u is the rows, right? The rows, it means u is greater than rows minus 1, or v is greater than columns minus 1. Okay, or the position at uv is already visited, right? Or the value at u and v is 0. It means if these conditions are satisfied, we will skip, right? We will skip. Else we will add 4 adjacent positions to the queue, right? Queue of last new int u minus 1, v q of last u and v minus 1, q of last u plus 1 and v q of last okay, u of v plus 1, right? So I think that's all. Let's check. Oh, no, we didn't update the islands, the number of islands, right? We will increase the number of islands when we start the check, right? We have islands plus plus okay, so I think that's all. Let's try. Oh, we have time limit exceeded. uh, uh, why? Because we have a new already queue and we offer INJ. Okay, we offer INJ. Then um, uh, okay, when we visit uh, if these conditions are not satisfied, it means we will visit the position uv, right? So we should mark the visited at uv is true, right? Okay, looks good now, and try to submit. Okay, accept. And yes, actually for this problem, even we don't have the breadth first search algorithm, but if we want to use the deep first search algorithm, it's still acceptable. Okay, so let's try for the deep first search algorithm. So for the deep first search, instead of using a queue, we will use the stack, right? Okay, so let's try. Let's change the current algorithm to use the deep first search to check whether it is correct or not, right? Okay, so change is to stack, and then we have stack, and if stack we will offer to the first, right? And then we will pull from the first stack, right? And then stack pull first. Okay, and then we will offer to the stack, offer first. Okay, try again. Okay, still accept, right? And try to submit. Okay, still accept. And with the same runtime and same memory, so I think doesn't matter for which algorithm that we are using. Both deep first search and breadth first search are okay for this problem.